Sorry, I'm Ricard Vilalta. I'm the chair of TeraFlowSDN, and Luis Schifra, the chair of the TSC of TeraFlowSDN. We will be riding this Hackfest. I will be doing the boring part, so I'm sorry. Try just to keep awake for 10 minutes, and then Luis will start with the fun. So, but I thought that it was necessary that we introduced a little bit what we are doing here and what TeraFlowSDN is. Most of you are aware of it, but just in case that you were just passing by and you have decided to enter to the room, just explain a little bit what is an SDN controller and what are we doing in TeraFlowSDN. So this is the agenda that Sylvia has already introduced. So let me jump directly to the what's the TeraFlowSDN. And basically to justify the need for a new network automation framework. We have seen in the last 10-20 years SDN controllers. SDN controllers are the network elements that allow to manage the different network equipment. They have been based on this SDN paradigm, the software-defined networking paradigm, where you bring programmability to your network. But what we target with TeraFlowSDN is to go one step beyond that, and we want to have a network automation framework which tries to fulfill all the different needs for operating your network. So we focus on how we are able to automate through the softwareization. And for that, we need to handle multiple different network equipment, and also we are able to handle different network domains. So that's our how networks are deployed currently. Typically, you have multiple domains, technological domains, administrative domains, even from multiple operators domains, and we need to handle this complexity, and we need a tool that helps us handling all these levels of layering of the network. So also we need to provide somehow some specific domain solutions to automate the network. That's what TeraFlowSDN is, and it results in a community. That's what we are here today, and on open source cloud native SDN controller, which enables smart connectivity services for the future networks. So who's who? They typically say who's involved in TeraFlow, and I have prepared this slide so it's clear who's the leadership. As you can see, the technical steering committee, that's the 5 are representative which take care of the different design decisions that the TeraFlow needs, and then the different members and participants. As you can see, here are the ones that are listed in the website of ETSI, and I have separated a little bit the academic ones from the different industrial ones. I think this gives networking community is not a huge community, as you can imagine, and you are all part of it, but it's very strong. So with a lot of ties and also some long-term commitment of the different companies on producing this software. So that's important. We are quite stable. We have just released last week, release 4, and this gives us some more advantage towards the next releases. So that's I wanted also to provide a slide that I thought it was interesting to see how TeraFlowSDN was related in this networking ecosystem. And for this, I wanted to show you very basically the behavior of TeraFlowSDN, because we have seen that some people only think TeraFlowSDN as an IP SDN controller, for example. Or some people think, okay, this can be a solution for optical networks. But TeraFlowSDN, depending on the different number of instances that you are able to deploy, it can help different purposes. And that's when you find here on top, in a hierarchical way, we have the parent SDN orchestrator typically, which allows us to provide end-to-end connectivity between the multiple networks. And then, as I was saying, we can have different SDN controllers which are focused on a specific network technology. Of course, for example, you could have direct control of the network elements all from end to end, but then this would not follow this layered approach that multiple operators are following when handling their networks. Then you can see that in this Encompass, we are also related to the other different Etsy projects, and this was a very easy way to show how, for example, we are related with open source Nano, and we are able to act as an end-to-end orchestrator for acting as one infrastructure manager. Or, for example, we have seen in the previous tutorial OpenSlice, we have also collaborated in order to deploy connectivity services directly through OpenSlice. So this is how all the different pieces of this feed, and I'm missing here on top OpenCapIF, which might export, and also here on top OpenCapIF might be used to expose different capabilities of the network. So this is the architecture that we have just presented for release 4. Just to be quick, you can see as a very big novelty, we have introduced a new data bus. So this allows us to have a different bus for the monitoring and telemetry data and the different communication between the components. So we have separated the service mesh that allowed us to communicate between the different microservices and the data bus that is being used to handle the monitoring and telemetrical data. This novelty has changed. I have one. Data bus has required a complete redesign of the monitoring and telemetrical framework, and also we have introduced a lot of new work on analytics and automation. So that's why we are targeting this release, as I was saying, a network automation framework, because a significant effort has been put in this part. Just to let you understand this architecture, on the northbound we have all the different APIs that we are able to fulfill. You can see that you can request connectivity services through layer 3 VPNs, layer 2 VPNs, also through some implementation of the TFS slice draft. Also, we are compliant with HCMEC bandwidth management 014, and also we have one small API for exporting all the information that there is no specific data model for that. Then at the southbound, you can see the different network equipment that we are able to control, which is many. For example, we are able to control IP routers, white boxes, all through the OpenConfig models, via netconf protocol or via GNMI protocol. Today we will learn a lot more about this. We are also able to control optical SDN controllers through the ONF Transport API, layer 2 VPNs. We are able to control transponders and muxponders. We are able to control also optical networks through the ACTN, SBI. We are able to program and configure P4 routers. And finally, we have also support for microwave links. All this with different services, which are here presented. And I think that they have one slide with some of the highlights for this release, which, for example, I recommend that tomorrow you go through them at the coffee breaks. You will see some demos for quantum key distribution using TeraFlowSDN as a QKD controller. As I was mentioning, a strong focus on end-to-end automation and monitoring. Also some support for network management, extended support for optical networks, and also extended support for optical network equipment. We have also introduced a new blockchain support for Hyperledger Fabric, and many other additional enhancements. This has been a very significant release with a lot of new features, and I hope that you enjoy it and you test it and you run it and that you use it, basically. So these are all the interfaces supported, which I have already mentioned. And this is the different communities which we have started to relate with. In this case, you can see that we have established a relationship with many open source initiatives at Etsy, but we have also established a relationship with different standard bodies and industrial organizations. So typically, we plan to be reference implementation for different standards, and that's our focus, and that's why we are here today. So I hope that this has not bored you enough, and that now you can start the fun with Luis. The floor is yours.
Thank you very much, Ricard.